analyze the IV characteristics of an solar panel. Okay, so what is this IV characteristics? Already I told we need to measure the IV characteristics and we have to find out the fill factor and we have to find out the efficiency of an solar panel. Okay, so how to find out these two parameters? We are going to do with a professional equipment. This called Metravi solar power meter. By using this Metravi solar power meter, we are going to find out the power density in terms of watt per meter square. Okay, so in order to measure this, the total amount of power density, we buy a new equipment. That's how we are going to reveal this, the importance of this tool and how to use this tool and what is the procedure of using this solar power meter. You can see here, this manufactured or it is made by Metravi. The model number is 207 and this is called as a solar power meter. Okay, so this is called a solar power meter. Okay, so you can coming to the specifications. This solar power meter will measure power density. Okay, how much power density it can measure is 1999 watt per meter square. Okay, it can measure the power density up to 1900 and so 2000 watt per meter square it can measure. So this is the specification of this meter. Okay, so coming to the next one, so it has a hold, I mean data hold. So for example, you recorded the value, you can hold the data in using this memory function. Okay, and you can data hold function to hold the measured value. Okay, so we are going to measure the input irradiation by using this meter. So it has an measuring unit selection, so you can change it for watt per meter square or in foreign units, British thermal unit. Okay, you can convert into your two required SI units also. Okay, so this is a manually. Okay, the lux meter is like lux meter only, it will measure adjustments. This is a perfect meter. The cost of this meter is around 25,000. Okay, to unbox this and you are going to see how to measure the each individual component and how this meter find out IV characteristics of the given big solar panel. Okay, so you see here, so when you buy in online, you will get the order like this. So just a safety pouch. In the safety pouch only everything is there. So this is the box, the Metravi solar power meter. So after unboxing, you will get an setup to carry the meter. Okay, so how to dismantle this is, so just open the what is given, the pouch is given and you will be having the meter. Okay, so this is the meter what is provided by Metravi. Okay, so you can see the meter. So just remove the meter from the box. Okay, and you can see an manual. So this manual is very important, how to operate that meter. Okay, so already we have been using this meter for number of days, so we have an clear function. So all the things are given, the introduction, what are the meter specifications. Okay, so I told this will measure power density up to how much range, 2000 watt per meter square. Maximum sunlight irradiation we are having less than 1000 only. So if the sun rate is double also, we can measure the solar radiation. That's why we buy this meter to measure the power density. What is the formula of power density? Watt per meter square, seems similar to that of an flux in magnetic, flux per unit area. Okay, and you can see to this, coming to the features of this meter. Sunlight measurement, sunlight means what? Solar radiation. This is called what? Which energy? Photon energy. We can measure this photon energy up to a maximum range of 2000 watt per meter square or convert into British thermal unit, which is nothing but feet square into height. Next, it is high accuracy and rapid response. It is exactly, it will give the value. Sir, without this meter, can I perform IV characteristics? If you perform also, it is not a valid. So there is no validation if you draw the IV characteristics without this meter. That's why we buy this and we are going to draw the IV characteristics. And you have data hold. So for example, you recorded, you can have the hold button. Okay, by using the hold button, if you hold it, the recorded value will be holded and you can plot this value or you can copy this value into your observation and you can start doing the calculation part. Next one, it has unit and sign display. Okay, I will turn on it and I will show you how it is works. Okay, so next one, it has a low indication and it has a maximum and minimum values. Okay, let's try to see the meter. Okay, so now I'm seeing keeping the remaining operators aside. So after buying the meter, what you have to do is this is called a cap is provided, a safety cap is provided, and here you are going to have an luximeter which measures the power density, and after you just remove, and a telephone wire is provided like this where you can measure. So here how to turn on is you'll be having an meter like this. So you have an buttons. How many buttons are there? One is power button, one is unit conversion, watt per meter square, next one is the range, how much range you want. Okay, so coming to, if you turn this side, you are going to have hold. After recording the value, you want to hold that value, you can hold in this meter. Next one, you can find the minimum value up to now, how much is there, and what is the maximum value this meter has already recorded, and this is the display. If for example you are recording in sunlight, you don't see this value, so in order to have a display, we have an light here. Okay, so inside this you have an battery backup, it's already given. Okay, so now just unbox the content, just open the lid, and you see here what is the procedure of turning on it. Just press the power button. When you press the power button, so you can see here, so this side you have an light, so when you press it, automatically it is like LCD display. So when you press this button, automatically the light will start glowing. Okay, so whenever the light starts glowing, you can see the readings. Now it is showing how much, 12.9 BTU, but we never measure in British thermal unit, we expressed the units already in watt per meter square. You have an option of conversion, just press the W button. So when you press the W button, how much it is indicating? 28 watt per meter square. Now we'll start the experiment and we will do it. Okay, so that is how to first press the power button and then press the watt button. When you press this watt button, automatically the units are changed from watt per meter square to BTU. Okay, and then we want in watt per meter square, we recorded, and this is nothing but a range. So now we'll take into the sunlight. Will take into the sunlight. So now we are kept in sunlight. What it is showing? Overloaded watt per meter square. Then which button you have to press is rotate the meter like this. You have a range button. You press this button. So now you see here. So write down the value. How much you are going to get? So now the sun radiation is how much? 740 watt per meter square. Okay. So now you got this value. So I cannot write down at this instant. I want to hold it. Just you can press which button? Hold button. If you press the hold button, the value is holded, and it will be indicated as the value is holded. So what is the option it's indicating? The value is hold, and what is the value of the solar radiation which is available from the solar radiation? 736 watt per meter square. So, and you have the next button is maximum or minimum. Okay, so after completing, you just unhold it. Okay, now we are going to measure the IV characteristics of that solar panel. I am going to keep the solar panel. So the solar radiation we are going to measure. So whatever the radiation is falling on it is directly falling on this meter also. Okay, how much they are going to get? 736. Now how to record this value? Just hold the button. Okay, so now bring the value. Okay, so you can measure. So what is the value you are getting now? We are going to find that value. So how much value you got? 720 watt per meter square. So similarly, now we are coming into the sunlight. So when you have your mobile, if you already had hold it, so you are not only it measures the sunlight, it can measure your phone light also. Okay, you see here. So when you turn on your mobile phone, you see here, this mobile phone is also giving an heat. How much heat it is giving? You see here. Someone hold it. Shoot this. So this mobile is generating some light energy. When you keep it nearer to it, now how much it is showing? 75 watt per meter square. You understood the precision of this meter. So it can measure 0 to 2000. So you may think that, sir, where is the light energy? So this mobile is also generating what? Which energy? Light energy, where this is called solar radiation. So it can measure. So now here also you have, you are thinking that there only the radiation is there, but here also you have an radiation. What is that value? 88 watt per meter square. That's how it measures the light energy available in an atmosphere. That's how this meter is useful to measure the power density. Okay, so the denominator you are going to get watt per meter square, and you have to calculate the length of the solar panel. Okay, length and breadth of the solar panel, this is how it is going to. So after completing, we had recorded the minimum value as 80 and the maximum value as 120. If you press this button, so maximum value recorded is how much? 98, and minimum is 91 in this available atmosphere. Okay, so now we'll try to check it how to operate this meter. Okay, so now what is the recorded value? 746. Okay, so now already we calculated the power radiation from the solar meter. Okay, now let's try to do the calculation part. Okay, how to do the calculation part? So already, what is the formula for efficiency of a solar panel? Efficiency of a solar panel is equal to output power. So we'll try to draw this graph. Already you can see at the back of the panel. Everyone write down the panel parameters. Write down the Vm and Im of the panel parameters. Vm is 17.25 volts and Im is 4.7 amperes. So already it is printed on the nameplate details. How much you got? Vm and Im. So what is the formula for efficiency of a solar panel? Efficiency is equal to Vm is how much? 17.25 multiplied with how much? 4.7 amperes divided by output power by input power. What is the input power calculation you got? 740. What are the units you got? Watt per meter square. Watt by meter square into area. So how to write down the area? How to express this area in terms of meter square? So take a scale. So now we are going to find out the efficiency of this solar panel. We had got the values of voltage as 17.25 and current as 4.7 amperes. So now by using our power, solar power meter, we measured that value. Okay, so how much it is giving? Watt per meter square. So it is giving the maximum value. So it is giving maximum how much? So now we are clipping in directly to the sun radiation. It is showing beyond. You see here, when I turn it down, what is happening? The value is decreasing. So now we placed the solar panel with respect to the 45 degrees. The maximum irradiation it is displaying as 890 watts, approximately 900 watt per meter square. Okay, so now the time is 3 o'clock. That's why the temperature is aggressively rising. So as per the recorded value, how much we got? So we had got approximately 800 or 750 watt per meter square. Okay, into we have to what are the units? Watt per meter square. So now we want to calculate the length and breadth of the solar meter. Okay, so let's try to measure the solar panel. What is the length of the solar panel? So 30, and it is going to give a value of how much? 83 centimeters. Okay, this solar panel is having a length of how many centimeters? 83 centimeters. Okay, and the breadth of the solar panel, we are going to measure the breadth of the solar panel, which gives an value of how much? 62. So now this is 83 centimeters and this is 62. Add both. Okay, so sorry, you have to multiply the both 83 into 62 into centimeter square. 1 centimeter is equal to 10 into 10 to the power minus 2 whole square. If you perform, then you are going to get 0.514. Okay, so you multiply that value with 0.514. Okay, so when you multiply this value with 0.514, the units are watt per meter square. And what is the area you got from the solar panel? What is the area of the solar panel? 0.5 meter square. Meter square will get cancelled out. When you do the calculation, 17.25 into 4.7, you are going to get 81 watts divided by 380. So and you have to multiply this value with 100. So now you got what is the efficiency of the solar plant? 21%. So now I can say that this solar panel is working good. What is the type of solar panel? This monocrystalline or polycrystalline? This is an polycrystalline where you are having a blue patches. That's why it is called polycrystalline, made up of multicrystalline. So now it is by 10 years back, still it is able to deliver good performance. Therefore I can say that that panel is working good. So how to verify that parameters? You require the help of this which meter? Solar power meter, which measures power density in watt per meter square. Without generally how people do the calculation is, this denominator term they will consider as 1000, and they don't test in heat condition, and they don't test it afternoon 3 o'clock. So randomly they will take it as 0, which is an wrong method of calculation. This is how the proper method of calculating. Now the same we are going to plot the IV characteristics. Okay, so from IV characteristics also already explained in the theory, you will get one maximum power. With respect to that, you are going to get maximum voltage, and you are going to get maximum current. That also you can get from the graph. Let's try to do this experimentation part. So we are connected to the solar panel. What is the output of a solar panel? We are having one positive terminal and one negative terminal. Okay, so in order to design the safety, we already designed the safety. For example, if you are developing this experiment, how to design this MCB rating, how to design this fuse rating, and how to connect to the panels, let's try to discuss. Okay, so now what is the circuit diagram for this? You are going to have a solar panel which is like an DC supply. Okay, so this is your solar panel symbol, and you are having a positive terminal and negative terminal. So from positive terminal and negative terminal, I am going to connect an voltmeter. So before connecting to an voltmeter, I should enable an safety. So what is the maximum current that will flow in the meter? So as per the solar panel calculation, what is the maximum current that will flow, that will come from the solar panel? 4.7 amps. Okay, so maximum current that I can get from the solar panel is how much? 4.7 amps. Okay, so this sometimes it may be 4.7, or sometimes it may increase. Okay, so whenever directly we short circuit, here the current will be maximum up to how much? 4.7. Now we want to design the fuse rating of this fuse carrier. How much current fuse you have to insert to protect our equipment? Why? Because that is some 10,000 rupees, and this isolators, contractors is around some 5,000 rupees. Each meter is of around 5,000, and this is also of 5,000, approximately, which constitute around 30,000 rupees one project or one experiment. So we have to do some electrical safety while designing this experiment. That's why we use an primary fuse, secondary protection as MCB, which is nothing but miniature circuit breaker. This will try to act like as per the requirement. For example, if the current is beyond 10 amps, automatically this will fall down, or if it is beyond 30 amps, automatically this will fall down, and automatically you have to make it on. There's no need to rewire the fuse. So to enhance double safety, we use an MCB, and we are using an fuse carrier. Okay, now see the current calculation or how to design this circuit. So you have an solar panel. What are the output of a solar panel? DC supply. So you are having an positive, you have positive terminal and negative terminal. So in between this, you are going to insert an fuse in series, and we are going to have an MCB, miniature circuit breaker, and we are going to connect an voltmeter at the output, and we are going to connect an ammeter, and output of the ammeter we are going to connect to an resistive load, where this is called wire wound coil. And how much resistance we have kept here? 50 ohms. And maximum current, so the maximum current that will flow in our so this we are connected in what? Only one panel. What is the maximum current as per the panel? 4.7. so 4.7, that's why maximum I have to measure 4.7. That's why I kept an 5 ampere rheostat. Okay, here also I kept an ammeter, maximum restricted to 5. Okay, so here I am going to select the ammeter. Maximum rating is how much? 5 amperes. What the type of meter? Moving iron type. So voltage, maximum voltage, how much it is going to generate? 17 volts. So that's why I connected a voltmeter ranging from 0 to 30. Okay, so 0 to 30 voltmeter will measure how much voltage. How much voltage is going to give? 17 volts. 17 volts will be measured by this voltmeter, and current will be maximum measured as how much? 5 amperes will be measured by this ammeter. So now how to decide the rating of the fuse? So what is the maximum current we are having? The maximum current we are having 4.7 amperes. So we have to decide the rating of the fuse. So just do the calculation. 4.7 into 1.25. I mean 0.25 is nothing but 25% extra capacity will insert. Are able to understand? 1 means 100%, 0.25 means 25% extra capacity will insert in what? Fuse rating, such a way that at least it can withstand. So now multiply 4.7 into 1.25. 5.8. Very good. 5.8 amperes. Okay. So now I want to design a fuse with how much rated? 5.8. So 5.8 is not possible. You can have a maximum gauge of 5 amps, 10 amps. Okay. So now that's why I bought a fuse which can withstand a current of 6 amperes. Okay. So this fuse can withstand a current of 6 amperes. Okay. So this is called KitKat fuse. In this KitKat fuse, we insert the fuse current rating of how much? 6 amperes range. As per that 6 amperes, we decided the cross sectional area of this wire and we have been winded it. Okay. So now so it is going to close. Actually in the positive terminal one is sufficient. For better safety, when it's trying to close also, we given a double safety. Okay. So this is the rating. We decided the rating of the fuse carrier. And next, to enhance the second safety, we kept an automatically means hot. So here the fuse will blow off. Okay. If the current is higher, automatically the fuse will blow off. Again, what you have to do? You have to take the same cross sectional area of the fuse and you have to insert and you have to tighten the screw. It's a time taking process. So that's why if this doesn't close, we kept one more automatic. This is called miniature circuit breaker. So we kept it rating for an C 16 amperes. Okay. Minimum actually we thought of keeping higher rating, it's not available. So that's why the maximum current we kept up to C 10 amperes. Okay. So we have to keep which kind of MCB? 6 amps if possible, it's available. Since it's not available with your hand now, we kept how much rated? 10 amperes range and we connected the input. Okay. So now we are going to measure the IV characteristics of an solar panel. Okay. So now we understand how to design this equipment of your own. So doing experiment with already available circuit diagram. Show your circuit diagram. So already a circuit diagram is given in the manual. We have this manual. This manual is certified by Ministry of New Renewable Energy Resources. A circuit diagram is already developed. Okay. All the fuse rating, current rating and voltage rating, everything is designed there. How you design? If you want to understand, this is the procedure or the background of how the development is happened. Okay. All the time remember, if you want to design the fuse rating, how many times you have to have the extra range? 1.25% is nothing but 100% is 1, 0.25 is nothing but how much extra? 25% extra. Then we can identify the ratings of the fuse. Okay. So this is of 6 amps, this is of 10 amps. So now we are going to connect. So as per this circuit diagram, we are going to give the connections. Okay. So now see here, the solar panel is there and it is white. And what are the inputs of the solar panel? DC supply, this is positive terminal, this is negative terminal. So from that positive terminal, we are given to the input of the MCB, and on output of the MCB we connected to an secondary fuse. Okay. Output of this we use an contactor. This is called as like junctions. Okay. This heavy gauge junction, we had connected the positive here, we had connected the negative. So as per the circuit diagram, first we have to we have to close the circuit. Yes or no? So how to close it? From positive we have to connect to the ammeter. Okay. From positive. Okay. So take the positive wire and you try to connect to the ammeter positive. This is the ammeter positive connection. Okay. So current is current all the time enters into the ammeter as which terminal? Positive terminal. Current will leave at which terminal? Negative terminal. So from this negative terminal we are taken and this is called wire wound coil. This is called as wire wound coil. So this wire wound coil will have 3 terminals. Okay. So this is called input 1, this is called input 2 and this is called this is called output. This is in technical, it is also called a rheostat, where the resistance can be adjusted from maximum value to minimum. So you see here how to perform the experiment. We had given the input here, so current will start flowing. It completely flows this coil and the current will be collected at this carbon brush and it will come out like this and the output we are going to connect at this point. Okay. So we can use this for variable resistance or fixed resistance or for as a potential divider. Okay. You connect the positive terminal here, negative terminal here, you take the output and you connect the negative here, automatically this will act as an potential divider. Okay. So this can function 3 parameters, but we are using only for one purpose, that's nothing but we have to adjust the resistance as an rheostat. So now I had connected the input here, okay. So output of the ammeter I had connected to the input here, and output of the rheostat, and how to close it. So see the circuit diagram, how to close it. The output of the rheostat is connected to the negative terminal, okay. So this is the output, we are connected to where, the negative terminal, this is the negative terminal. Now we have been closed it. So now with respect to this connection, this voltmeter is connected in parallel, okay. So that's why I taken one positive terminal, this is a positive terminal, this is negative terminal, I had connected the voltmeter in parallel, okay. So now the circuit diagram is completed. So the maximum current will flow in this circuit as per the solar panel design. Maximum how many amperes? 5 amperes, which is as per the design 4.7 amps only will flow. We designed the safety for, if you overload it, definitely this will break down or this will blow off, or if it is not blowing off, automatically this will blow off. There is no concept that this equipment is going to damage, okay. So this is what the functionality of taking of these parameters, okay. Now let us try to see the procedure. So how to, what is the procedure of doing the experiment? So you have to record the values of voltage from the voltmeter, you have to record the values of ammeter, and you have to adjust the rheostat, okay. Let's try to see here, we had connected the solar panel. Now what is the position of the switch? Off. What I have to do now? We have to turn it on. So we are going to turn on, and we are connected in which range? 60 volts range. Everyone write down the readings. Serial number 1. So first observation, serial number 1, voltage. See the voltage value. So come here and say the voltage value. So 7.589, okay, 9 into 9 into 2. 9 into 2 is how much? 18. So as per our design parameters also, how much voltage you are supposed to get? 17.25. So now we are having more amount of sunlight, that's why it's generating beyond the capacity. So how much value you are going to have? So approximately 17.25 or 18 volts, okay. Write down the voltage is 18 volts. So now what is the position of the rheostat we kept? So this is the input we had given, and this is the output, okay. So now what is the value of the resistance, minimum or maximum? So current will start flowing from here, it will completely flow in this branch and it will be connected. So what is the formula of how to identify the whether the rheostat in minimum or maximum position? R is equal to rho L by A. So what is the length of the coil? Length of the coil is maximum. If the length of the coil is maximum, what is maximum? Resistance is maximum. What is the formula for current? Current I is equal to V by R. Current I equal to V by R. So now what is the position of the resistant? Maximum resistance. If resistance is maximum, how much current will flow? Low current will flow. You see here how much current is flowing? Very low magnitude of current is flowing. So you can see your ammeter which flows very low magnitude of current. 0.2 amperes. Let's try to take some set of readings to draw our IV curve. So you have to draw the IV curve like this. Let's try to take some set of more values, okay. 0.1, 0.2. So current is 0.2 into 1, and voltage is how much? 18 volts. So second set of reading. So I will take how much the maximum current will flow? 5 amperes. I will try to load as per the requirement, okay. So we are trying to move the resistance. You see how much it is? 0.2. Let's try to go for 0.3. So this is 0.3. Now write down the current. 0.3, the voltage value is again 9. So 9 into 2. 9 into 2 is how much again? 18 volts. Okay, just you scale 2 times. Why? Because you have the upper scale is 30. Bottom scale is 30. Upper scale is 60. How to convert 30 into 60? By multiplying 2 times. So we have to multiply that value into 2. So next, how much you are getting the current here? 0.3. Let's try to mark it for 0.4. So write down the current 0.4 into 1, and what is the voltage you are going to get here? 9 into, see the voltage how much you are getting here? 9 into 2, same voltage. Why? Because the panel is having same irradiation, okay. So next one, we are going to increase the current. So how much we are by wearing this rheostat? We are increasing the current. What is the current now? 0.5 into 1, and what is the voltage you are going to get? 9 into how much? 2. Again 18 volts. Now current is 0.5. So slowly I am increasing the current. So now how much is the current? 0.6. Current is 0.6 into 1, and what is the voltage? 9. 9 into 2. So similarly, now I am going for 0.7. 0.7 into 1. 9 into 2. Next one, you see here, you can see the coil is getting heated up. Okay, so come and see the coil, whether the coil is getting heated up or not. So this is the input, and this is the output. Okay, so you can see the coil is getting heated up. So you may ask a doubt, sir, experiment is going on, you are directly touching with your naked hand, why you are not receiving any shock? So I have a safety with shoe, and operating level is very low, only DC supply 12 volts, that's why maximum current doesn't flow. Okay, actually you should use safety gloves as per personal protective equipment, and you should use the proper insulation. Okay, so that is how actually you are supposed to do. That's why we have to hold at the insulation part, only at insulating parts we should not touch it. Okay, so now let's try to see whether it is heating or not. So now I am going to load it up to 1 ampere. So what you got? 0.8. So now this is 1 into 1. So see the voltage rating. Now you see here, load is increased, automatically what will decrease? Input voltage will reduce, is called voltage regulation or voltage drop. So if the external load is increasing, automatically what will happen? Voltage, input voltage will decrease. So this is how much? 8 into 2, 8 2s are 16. So previous it was 18. So voltage is decreasing. Now you see here, so you will proceed for 1.2. So this is how much? 1.1. 1.1 into 1. What is the voltage? 8 into 2. So next set of reading. Okay, you see here, don't load it very closer. You see here, now itself is burning. So if you leave it for 5 to 10 minutes, this red coil will become like a resistive load, like bulb. How your bulb glows, this will glow like this, and it will short circuit. If it damage also, our equipment will not damage. Why? Fuse is there. After that, what is there? MCB is there. Okay, so let's try to take the next set of reading. So be careful while you do this experiment. How much? I'm going with 1.2, 1.1, 1.2. So 1.2 into 1. What is the voltage? 8 into 2. Next one. I'm directly going with higher values. Be careful, see that it's getting a red color or not. 1.5 into 1. 1.5 into 1 is how much? 7. Now you see here, for 1.8, voltage is once again decreased. 7 into 1. Next one. So 1.6. So 1.6 into 1, 7 into 2 again. Okay, so next one. So don't go beyond this. Okay, it will produce arc. So maximum I am loading. So don't go like this. 2.5. Write down the value. 2.5 into 1. So current is 2.5 into 1. Voltage is 5. So you have to come to original condition again. 5 into 2. So you can see here, this coil is fully heated. Just check the coil whether it is heated or not. You check the coil, check heated or not. So coil is getting overheated. I mean, this is acting like an 100 watt. So this is acting like an 100 watt, and it is the complete power generated is absorbed here. Okay, so after doing the experiment, we have to bring the resistance from minimum to maximum. If you bring it to maximum, automatically current will decrease. So, and how to start the experiment? Start with maximum resistance, slowly decrease the resistance. We can see here the current value will slowly increase. Okay, don't short, you should not short the terminals. Okay, you should be careful and slowly what you have to do, increase the resistance. As soon as you increase the resistance, your meter also current will slowly, it will decrease, and it will come to the original condition. This is how to perform the, now you got different values of voltages, and you have different values of current. Take a graph sheet, and x axis you take voltage, and the y axis you take the current. You plot a graph, then you will get this graph. So from this graph, already we determined the efficiency of the solar panel as how much? 21%. So from this efficiency you calculate fill factor, and you calculate efficiency. If you calculate the efficiency, the same you will be getting, which is nothing but 21%. But Vm Im we directly taken from the solar panel, but from the graph what you will be getting? You will be getting Vm values and Im values. So from this Vm and Im you substitute in the form efficiency formula. Okay, so for this you have a graph sheet. So write down the open circuit voltage, short circuit current, and if you substitute here you will be getting the efficiency again. So this is how to identify the efficiency of a solar panel and fill factor of an solar panel, and what is the output of this result. So successfully we tested the life of the solar panel, and the conclusion is the solar panel is working well after our test. This is how to a detailed structure, how to design the experiment, how to perform the experiment, and how to get the required output. So hope the experiment is useful. Thank you.